What is gravimetric analysis? It is the technique in which the amount of an analyte which the ion being analyzed in a sample that can be determined by converting the analyte to some product with change of chemical state of the analyte, where mass of the product can be measured.
Whitening creams are widely used cosmetic product in daily life, especially for skin protection and aesthetic purpose. One of the common ingredients found in this product is zinc oxide, with the chemical formula ZNO, which functions as a skin protectant and whitening agent. However, the concentration of zinc oxide in cosmetic product must be carefully controlled, as excessive amount may cause skin irritation and health concerns. Therefore, analytical methods are required to accurately determine the amount of zinc oxide present in whitening cream. In this application, gravimetric analysis using the precipitation method is chosen because it provides high accuracy, good precision, and does not require complex instrumentation. This makes it suitable for quality control analysis of zinc oxide in cosmetic product.
The precipitation method is one of the main type of gravimetric analysis. In this method, the substance is being analyzed is converted into an insoluble solid called a precipitate through a chemical reaction. The precipitate form must have a known and fixed chemical composition so that its mass can be used for accurate calculation. During the process, a precipitate reagent is added to a solution containing the analyte. This reagent will react with the analyte ion and form a solid that does not dissolve in water. The precipitate is then filtered, washed, dried, or heated and weighed. The mass of this precipitate is directly related to the amount of the original substance present in the sample. In the case of zinc oxide determination, zinc ion will react the precipitating reagent to form an insoluble zinc compound. After heating, the compound is converted into pure zinc oxide, which is weak. Because the precipitate is stable and its composition is known, the precipitation method allows the amount of zinc oxide in the whitening cream to be determined accurately. According to cosmetic safety regulation, zinc oxide is considered as safe in whitening cream at concentration of up to 25% by weight. This limit is set by regulatory agencies such as Natural Pharmaceutical Regulatory Agency (NPRA) in Malaysia, and is also consistent with international standard Asian, EU and FDA guideline, which ensuring that products containing zinc oxide within this range are safe for topical application.
The objectives of the experiment have three main points. First, to determine the amount of zinc oxide present in a whitening cream. Zinc oxide is a common ingredient in cosmetic products, and knowing its amount is important for both effectiveness and safety. Second, this experiment aims to apply the gravimetric analysis method. By using precipitation, filtration, drying, and weighing, we can accurately determine the amount of zinc oxide in the sample. Lastly, this experiment helps us to understand the importance of quality control in cosmetic. Accurate measurement of ingredients ensures that cosmetic products meet required standards and are safe for consumer use.
Apparatus that we use are analytical balance, desiccator, beaker, filter funnel, pekebal tong, kekebal, hot plate, filter paper, and glassware. Then, chemical and reagent we are using: leaf-wood zinc oxide whitening cream, dilute hydrochloric acid, sodium carbonate solution, and distilled water. Procedure. Firstly, a quick weigh 2.0 gram of the whitening cream sample and transfer into a beaker. Next, add dilute hydrochloric acid (HCl) and heat gently to dissolve the zinc oxide present in the cream, forming soluble zinc chloride. After that, filter the solution to remove solute impurities and collect the clear filtrate containing zinc ion. Then, we add excess sodium carbonate solution slowly with constant stirring. We digest the precipitate by gentle heating to obtain a pure and easily filtrate precipitate. As the next step, filter the precipitate using a pre-weight cokeball. We then wash the precipitate with distilled water to remove impurities. We continue to ignite the precipitate to convert it into zinc oxide. Next, cool in a desiccator and weigh accurately. the weight of zinc oxide precipitate is obtained. Lastly, the amount of the zinc oxide present in a whitening cream is determined and compared with possible limit to assess safety.
First, zinc oxide is dissolved to form zinc ions in solution. These zinc ions then react with the precipitating agent to form a solid zinc compound. The mass of the precipitate obtained is 0.240 grams, and the molar mass of zinc oxide is 81 grams per mole. Using this, we calculate the number of moles of zinc oxide formed. Since 1 mole of zinc oxide contains the mole of zinc, the moles of zinc are the same. We then convert the moles of zinc into mass using the molar mass of zinc, which is 65 gram per mole. From the calculation, the mass of zinc present is 0.1924 grams. Finally, the percentage of zinc in the sample is calculated by dividing the mass of zinc by the mass of the original sample, which is 2 grams, and multiplying it by 100. The final percentage of zinc in the sample is 9.63%. This result shows the amount of zinc present in the given sample. In this experiment, the zinc oxide content in the whitening cream was determined by using gravimetric analysis. The results show that the cream contains about 10% of zinc oxide. The relatively high percentage is expected because zinc oxide is commonly used in cosmetic products as a whitening and protective agent. It also helps protect the skin from UV radiation and irritation. During the heating process, the organic components in the cream were removed. This step is important because it leaves behind pure zinc oxide, allowing an accurate measurement of its content. A zinc oxide concentration of 10% is considered safe for cosmetic use, as it falls within the limits approved by regulatory bodies such as FDA and the European Union, which allow up to 25% zinc oxide in skincare products. Overall, this experiment shows that gravimetric analysis is a reliable method for determining zinc oxide content and is important for quality control in cosmetic products, ensuring both effectiveness and safety.
Conclusion: the percentage of zinc oxide present in liquid zinc oxide whitening cream was successfully determined using gravimetric analysis. By precipitation, zinc oxide in the cream was separated from other components by acid dissolution, followed by precipitation and ignition to obtain a stable zinc oxide residue. Heating and weighing to constant mass ensure complete removal of moisture and volatile substance, further improving the accuracy of the result. Based on the mass of zinc oxide obtained, the percentage of zinc oxide in the cream was calculated to be approximately 9.62%. It is within the permissible safety limit 25% of cosmetic product, indicating that the whitening cream complies with cosmetic safety regulation. This method was found to be suitable and reliable for the quantitative determination of zinc oxide in cosmetic cream product.